Get out of there.
If you play with cars long enough, odds are you're going to have to repair a wiring harness at some point. Whether that's an accident, critter damage, wear and tear, the wiring harness rubbing on stuff it shouldn't be, it's going to happen at some point. But here's how you do it. Classic or new car, you got to verify the fault. What's going on? In this case, it's throwing a check engine light, and we're going to find out what it's saying.
I've been watching this for a little while now, and the temperature gauge goes anywhere from full cold to full hot and anywhere in between. Using my Innova 5610, there will be a link in the description to this guy, I've got a check engine light for a P0118, which is engine coolant temperature sensor. And that's consistent with the location. That's right next to the coolant temperature sensor. Another way you can do this is to look at the live data. ECT, engine coolant temperature, 91. I know for a fact it's not 91 degrees out here. And when I looked at this last time, it showed 260 degrees Fahrenheit when it was ice cold. So we know we've got a problem on the temperature circuit side of things. The critter was hanging out right there. This right here is the coolant temperature sensor, and that puts everything in line, meaning that's getting chewed up right there. So next thing is to undo your battery. You're playing with electrical stuff, you don't need to have problems while you're working on it. So undo the battery. On this car, it's behind that wheel, so see you in a minute. Well, that was fun. So from here, it's really going to depend car to car. You need to get access to the wiring harness, and you need to remove plastic panels, various things to make sure that you can work around it. You're able to get in there, strip wires, add new wires, take care of the stuff that's broken. In my case, I got to take the upper intake manifold off this, so we'll be back in a minute. In this case, everything's now disassembled, and I can start to get to the heart of the issue. So when you're doing this, you need to carefully remove the outer cover, the outer sheathing, so that way you don't hurt the wires any further than they may already be. I've got a very sharp brand new razor blade here, and I'm slowly picking this apart. Keep in mind that if you're in some place where stuff can be a problem, make sure you block it off. So I'm now to a point where I can start to fix individual wires. And this harness runs all the way over to the throttle body on this car, and unfortunately that's really hard to get to. So I'm going to start with this black one here, and basically I'm just going to cut right at the brake. I'm going to use one of my wiring connector kits. This happens to be one of my Dorman ones, and it has a whole bunch of nice connectors. I'm going to use one of those, a heat shrink tube, crimp it back together, and you know, the crimp versus solder debate really isn't an issue, and I'm on team pro solder, but for this case, since every connection starts with a solid mechanical connection, I'm going to cut it, crimp it, and heat shrink it, and it'll be good for a very long time. When I'm done, I'm going to rewrap the whole harness in some nice harness wrap. So there's really two main types of repair terminals you're going to use. You're going to use something like this, which is considered an insulated terminal, but when you crimp it, it already has, you know, a hole, it's got some sheathing around it. At least it's a little safe from anything, you know, touching the outside, but it's not very weatherproof. And then you have the non-insulated variety, which is actually my favorite. Use the non-insulated and a piece of heat shrink to essentially go over it, and you hit it with a heat gun, and it makes a weatherproof kind of connection. Now, every connection begins and ends with a solid mechanical connection. If it's not got a good mechanical connection, you're out of luck. So when you're making these connections, you got to look at your wire crimpers. They're going to have both an insulated and a non-insulated section. You need to make sure you're crimping the connector that you're using with the correct crimp style, otherwise it's not going to be a mechanically sound connection. Now, crimping the non-insulated actually makes for the most positive crimp out there, because it essentially makes a nice little divot and D shape into things. So when you crimp it down, it really holds onto the wire really well. So whether you crimp or solder connections, it really doesn't matter. The thing that really does matter is making sure you weatherproof them when you're done. Using a good quality heat shrink is going to make a huge difference on the longevity of these repairs. You want it to stick around for a while, right? And if you're interested in learning a little bit more about that crimp versus solder debate, check out this video up here after this one's done. So this is just more of the same. You just keep doing it over and over and over again until all of the wires are repaired. This is just strip, crimp, heat shrink, and repeat. So now that I've managed to repair all the damage that stupid squirrel made, I'm going to go after it with some fabric
style harness wrap. This is going to make it look as close to factory original as possible, as well as keep everything bundled together nice and neat, and just help keep stuff out of the connections. As you can see, the project's done. The car runs great. The coolant temperature comes up like it's supposed to, and in that harness was also a whole bunch of injectors and stuff. I'm very surprised that I wasn't seeing any engine misfires or injector issues there too. But the good news is it's fixed. And I'm going to have to find that squirrel and get rid of him, because frankly, him and his friends are causing me nothing but trouble. Thanks for watching, guys. And if you like this one, check this one out over here. I know you like that one too.